cosine of theta. Now we're going to use this property again, right?
Yeah. Yes.
So this right here is magnitude of u squared minus 2u dot v plus this one again is magnitude of v squared equals that side. And do you see what cancels? So this cancels with that, and this cancels with that. And so at the end of the day, we're left with negative 2u dot v equals negative 2 magnitude of v magnitude of u cosine of theta. And then the negative 2's can just go away. And there you go. That's it. So that is why the dot product is equal to this. Now once we have that, then we have a lot of results that come of that, all right? But that's just a quick sketch geometric proof using law of cosines. I believe the book has something in there about that, if you want to run through it again. How are we doing? What time are we out of here? Got another half hour?
We got about 30 minutes.
Brutal, brutal.
How do you think we feel? We're just here.
I know. At least I'm sitting here, right, and I'm like moving around talking.
You're moving around talking. You're standing up. You're
Standing
doing
up.
plus one.
Do y'all want to do some push-ups or something? You don't want to? You sure? Okay.
It's a teddy bear.
All right. So the main thing here that we want to take away from this where's the theorem? I think I have it written out. Hold on. See if we can take the main idea out of this. If somebody hands you two vectors and asks you whether or not they are orthogonal, that means they are asking you whether or not they meet at a right angle. Then what do you have to do to check? What would the dot product need to be? Zero. Right? So all you have to do to check to see if two vectors are orthogonal is take the dot product. If the dot product is not zero, they're not orthogonal. Super quick, easy check. So are these orthogonal or not? Well, let's take v and dot it with u. So what's v dot u here? 2 times 6, that's 12 plus, negative 12, right? That's 0. Are these vectors orthogonal? Yes, that's it. That is a very fast check, isn't it? It's a very fast check. So let me give you something that I think is a little more profound than that. Let's say we have 3 points in space. Say we have the point 3, 5, 7. Let's say we have the point 0, negative 2, 1, and we have the point 6, negative 4, 2. All right, take these 3 points in space. I'd like for us to create a triangle out of these. All right? So imagine, it's hard to draw this, but just imagine we have these 3 points. Let's call this one A, let's call this one B, let's call this one C. And let's just imagine we've got this triangle. I have no idea what this triangle looks like, okay? So I don't know if it looks like that at all. Okay? My question to you is this a right triangle or not? Just think about how difficult this question is. I give you 3 arbitrary points in this room, right? 3 arbitrary points in this room and draw a triangle. Figure out if it's a right triangle. How difficult is that question? Yes?
Wouldn't you just get all the dot product? Wouldn't you just use the... You have to find the vector first, and then use those vectors to find the dot product.
That's exactly right. So when I say how difficult is this question, how difficult is this question without the dot product?
Yeah.
Okay, so if you were trying to do this without the idea of the dot product, geometrically, how are you going to do that? You know what I'm saying? Like, I guess you could figure out the distance between points, right? So you would know the lengths of the sides, right? You could probably do it. But for us, let's just check. How would we check this angle right here? Let's call this theta 1, because there's actually 3 angles. Call it theta 1. How could I figure out if theta 1 is a right angle?
You define the lengths of the vectors AB and AC.
I need to find the vector, right? I need to find that vector AB, and I need to find the vector AC, and then dot the two, right? But the key is you have to create the vectors. You can't work off the points. You have to create the vectors. So what's the vector AB? So AB is what? Say again? We're going from A to B, right? So -3, 7, -7, and then -6. So if we're going from A to B, we're going to take that, subtract that, that subtract that, that subtract that. Right, so there's AB. And then the other vector from A to C is 3, -9, and last, -5. Okay, so now we have these two vectors, right? Let's dot them real quick. AB dotted with AC is, right, we multiply, add this, multiply, add. So -9, positive 63, and then positive 30. No go, right? Right? This is not 0. So what can I tell you? I can tell you that it's that, well, that angle's not 90, right? I've got to check one more. Or both. Oh, no, wait, I think we have to do both. Yeah, because we could pick the wrong two, right? So that's not too bad, right? I mean, it took a little bit of time, but like once you become fast at creating the vectors, dotting them is pretty simple. Is that a question, or?
So add up to 1/8.
What do?
The 3 angles. We don't need to do all.
Yes, but we don't know what the angles are. We're not actually finding what the angles are. We just know that this one's not 90, right? So this one, if we check it, if it's not 90, that one could still be 90, right? So unfortunately, we have to check them all. So we basically would have to create 6 sets of vectors and do dot products. But some of them are pretty easy because when I do my vector from C to A, right? It's just AC, change the signs. All right, I'm going to leave this alone. I don't want to continue with this. We would continue checking. So maybe it would be worth it for us to actually find the angles. Like if we knew that that wasn't, we know it's not 90, but what is it? Because what if this turned out to be 35, and then that one turned out to be, I don't know, 62, then we would know that that one's not 90, right? So I wonder, is there a way that I can actually get the angle? Rather than just saying, okay, if it's 0, it's 90, but what if it's 2.7? Like what? Do you think there's a way we can just get the angle?
Yes.
Yeah, it's got to be. Look. Take a look at this formula right here. Okay? Solve for theta. So divide these on both sides. Divide this through, and take our cosine. And that's where you get that formula right there. If you take that formula and solve it for theta by dividing both sides by the magnitude of u, magnitude of v, then taking the inverse cosine, you have a formula for theta. So if somebody gives you 2 vectors and you want to know the angle between them, then that's what you need. So take a look, let's take a look back at the problem we just did. What was the vector AB? I erased it. The vector AB was,
-3, -7, -7.
they're all negative. And then vector AC,
3, -9, -5.
okay. So we already did the dot product here. Oh, -5. We did the dot product, right? What was the dot product of these? We never can, we just said it wasn't 0, but what was it?
63.
Okay, so -9 plus 63 plus 30. It's 93, right? Take away 9. 84. Okay, so we got 84. We knew it wasn't 0, so we knew it wasn't 90. But in this formula, see, we're going to have to take our cosine of that dot product. So we're going to need that, but we also need the magnitude of each of these. So that kind of sucks, but I'm going to take the magnitude of AB, which is the square root of 9 plus 49 plus 36, which is root 45. Is it? 94?
Yeah.
Okay, and then the magnitude of AC, which is root 9 plus 81 plus 25. What is it, 115?
Yeah.
115. Okay, so what I'm doing is I'm taking the two vectors, I already dotted them, which is going to give me the top. I need find each magnitude that's going to give me these two, and now I need to take our cosine of that. Does that make sense? Okay, so theta is going to be, or theta 1 is what we called it a second ago, is going to be arc cosine of 84 over the square root of 94 times the square root of 115. So you'll need your calculator for that. And you can either get that in radians or degrees. So what do you, anyone get that yet?
Wait, so it doesn't matter if you're in either one?
You just need to tell me what your answer is. You either tell me it's this radians or this degrees. So we'll see if we can get any answers here. Was it Danny? Danny? Dan? We're waiting on you. You're the calculator, I guess.
36,
What did you get?
36.1
Degrees? 36.1 degrees. Okay. Verify? Yes? All right. So that's how we could go about just figuring out the angle. And then we could do that for the other two. It's kind of time consuming, but it's a very nice way to work with things in three-dimensional space. Okay, I think we're at a good spot. I think we might cut out a little early today. What, where's he have 20 minutes? I'm further into this than I wanted to be, which is okay. Can we sign in? Unfortunately, I have to do this. So this is going to have your name, it's going to have the date, and just initial in your column there. And while that's going on, I'll just talk through this example. Example 8 says, gives you the vertices of a triangle. So it's the problem I just did, give you 3 points, and determine if it's a right triangle. That's exactly what we were just doing. So not going to work through that example. We will start next class with vector projections. And I think after that, we'll start to get into what feels more like the calculus, hopefully. All right. So make sure you do the homework. If you've done a bunch of vector stuff, you feel comfortable,